Okay, so for part A of this lab, you're going to observe the burning of a magnesium ribbon. So we're going to start by lighting our Bunsen burner, and the procedure says to hold a magnesium ribbon, which I have. Once our Bunsen burner is lit, we can take our magnesium ribbon, which is here. We hold it in the flame until it begins to light. You can see the flame start to go, and now it's burning, and now it's burning, and it's releasing a lot of light. And you can see that there is something happening to the metal, and now it is all just a little bit of a snaky substance that is a different color. And if I shake it, it falls and crumbles. Here is the remaining ribbon that didn't burn, and then this is the part that did burn. There's more of it. Alright, and that's part A. So record your observations and describe the whether or not a chemical reaction took place, and determine what type, if any, of chemical reaction took place. Alright, so for part B of this lab, we're going to be observing whether or not zinc reacts with copper sulfate. So the first thing that we're going to do is take our copper sulfate and add 3 milliliters of it to a test tube, and we have this handy reference volume here to show us how much 3 milliliters is, so we don't have to measure it every time because that's annoying. You can see, notice the color of the copper sulfate. Let me just take a second here to put enough of liquid in here to really see what's going on. Notice the more liquid there is, the deeper the color becomes. Alright, so now we have our test tube full of bluish liquid, and that's actually, let's put our reference volume behind it. There we go, now you can really see that. Now we take our mossy zinc, it's just called mossy zinc because of its shape. We'll take one chunk of it, say about this big, and we'll drop it. Oh. Here, I'll let you get a good look at it. Notice its properties. Now we drop it into our copper sulfate solution, and the procedure says to wait 30 minutes. So we will come back and look at this in 30 minutes to see if anything happens. Alright, we're going to now check on our copper sulfate and copper experiment. See here that it appears that there has been a change that has occurred. I'm going to pour the liquid out and retrieve the metal. Notice here what has happened. The metal has suffered. There's also particles of metal left in the test tube, and this copper is now covered in a strange, I'm sorry, this was zinc, and now it's covered in copper, because there was copper in the copper sulfate solution. So that should give you a clue as to what reaction was occurring in that solution, and I will leave it up to you to hash out the details. So that was a piece of zinc, and now it is covered in copper dust. Alright, part C of the lab is the reaction of metals with hydrochloric acid. And you see here we have 3 metals. We have copper, we have zinc, and we have magnesium. And we have a bottle of hydrochloric acid here, 1 molar. So what we're going to do is we'll start by taking our hydrochloric acid and putting 3 separate 3 milliliter amounts of it into these 3 test tubes. And then we will add 1 of each piece of metal to the test tubes and observe the effect. I'm not going exactly to the 3 milliliter mark because it's not that important to get exactly that many milliliters. You just need enough to totally immerse the metal pieces and make sure that there's plenty of material for a reaction to occur. Right, so now we have our 3 milliliters of acid added to the test tubes, and I'll put this over here so that we can actually see it. And the first metal we'll put in is magnesium, I think. So here's magnesium. These are magnesium trimmings. We saw magnesium in part A, but this is sort of what it looks like. And then if we drop it into our test tube, you see something is happening. So based on that, you should be able to answer the questions about whether magnesium reacts with hydrochloric acid in the lab manual. The next metal we will put into hydrochloric acid is the zinc from the last part of the experiment. You can see I've got a pretty sizable chunk here, and I'm going to put it into hydrochloric acid. Now, this one is a little bit more difficult to see, but if you look really closely at the surface of the zinc metal, you might be able to see gas particles forming. And if you look closely, you may also see slight bubbles rising from the surface of the zinc metal. Now, you should notice a distinct difference between this and the reaction with magnesium. If I tap that, you see the gas bubbles coming up off the surface, which means that there's still something happening here. I'll do it again. More gas bubbles have formed. I wonder where they came from. Alright, and now the third metal that we're going to test is copper. So here we have some copper turnings. They're basically just broken up copper pipes, and various things. You can notice the physical properties of copper, its luster, and the way that it breaks. And then we will put this into its own hydrochloric acid container. And nothing happens. So those are three different chemical reactions of metal with hydrochloric acid. You notice in the first test tube, the magnesium is completely gone. In the second test tube, we still have zinc making gas bubbles. And in the third test tube, really the only thing that has happened is the copper looks cleaner. Alright, so just as with every experiment, we properly dispose of our waste. So this one, we pour all of our liquids into the liquid waste container, being careful not to pour our solid into there. And then we have a separate container for solid waste. And then here. And then this one has no metal waste left in it, so just pour it there. Alright. Alright, so in the next part, part D, we are going to test the reactions of various ionic compounds with one another. So the four compounds in question are potassium thiocyanate, iron chloride, sodium phosphate, and calcium chloride. You may have remembered the iron chloride and potassium thiocyanate from the anions and cations lab. And then these other ones are commonly encountered chemicals. So what I'm going to do is I'm going to start with the sodium phosphate and calcium chloride. We'll take 3 milliliters of each solution and add them to a test tube. So this is sodium phosphate. And this is calcium chloride. Notice the appearance of the liquids and observe them for your lab report. The thing about ionic salts is that when they are dissolved in water, they completely dissociate, and so the particles are not visible to the naked eye. So now we have these two colorless liquids in test tubes, and the procedure says to add one to the other. So we'll take calcium chloride and we will pour it into the sodium phosphate, and you see there something has occurred. So obviously a chemical reaction has occurred, and I leave it up to you to tell me what chemical reaction and what type of reaction that might be. So that is sodium phosphate and calcium chloride. Part D2 concerns iron chloride and potassium thiocyanate. So we'll put each of these into a test tube as well, starting with iron chloride. So the iron chloride, notice this one is a bit different than the previous two. It has color. And then iron potassium thiocyanate. And if we now add one to the other, we see what happens. And if you noticed, hopefully you noticed what just happened. We have caused a chemical reaction to occur. And I leave it to you to tell me about that chemical reaction. So that's part D. Once again, we will use our handy dandy waste container to dispose of our liquid waste. Right. So in part E, we're going to take some hydrochloric acid, as we did in our last part, and this time we're going to add sodium carbonate to it and observe whether there's a reaction. We'll start, as always, by putting 3 milliliters of our liquid into a test tube. And observe its appearance. And then we have sodium carbonate. It says to obtain an amount about the size of a pea. So we'll say that that's roughly the amount we're dealing with. Notice that it's a fine powder, but that it's only loosely crystalline. So now I'm going to add this to the hydrochloric acid. Notice what's happening. Notice the production of a gas. So now, you might wonder, well, what is that gas? Because it could be hydrogen, it could be oxygen, it could be carbon dioxide. The way that we determine what gas it is whether it puts a flame out. Because if it puts a flame out, then it's probably carbon dioxide. So I have a lit match here. And if I put it into the thing, oh, look at that. It smoked out immediately. It's almost as if there was no gas and no oxygen for it to consume. So that is the reaction of hydrochloric acid with sodium carbonate. And you saw that the gas produced by the reaction put out a match. Alright, so for the last part of this experiment, we're going to test the reaction of hydrogen peroxide in the presence of potassium iodide. So hydrogen peroxide is here. This is a 3% solution available from any pharmacy. I'm going to just pour it into the test tube because it's from a bottle. And then we have potassium iodide. We place in the other test tube, noting their appearance. And now I will add the potassium iodide to the hydrogen peroxide solution. Notice that a change has occurred. And I will let you also notice the bubbles forming inside of the solution. They're faint to see, but you can also see bubbles forming on the inside surface of the glass. So, in addition to the obvious change that has occurred, there is a subtler change that is also occurring. And I will leave it up to you to ascertain the source of that. Now, as always, we will dispose of our waste properly by pouring it into our liquid waste container.